talked about this. I know you guys already know that I'm a designer myself and contractor, blah, blah, blah. So the things we're going to go over, how to specify a pump, pump basics, some different project examples, also our JIF form or job information form. That's really key to really that's really the main thing we need to get you the pump specs. And then the specs that we actually provide, and then what the lead time is. So we'll go through that. Now, on pump basics, and how does it work? Well, not everybody knows the pump components, and also they don't really know, how it works. So what we do many times is we'll do like a pump tour, and we come to your office and we bring a pump with us. But between COVID and everything else, Mike's nice enough to, I'm going to stop my share here and give it to him. And hopefully he's got a pump somewhere at his house that we can look at.
Yeah, absolutely. So, Mark, keep chatting. Give me 30 seconds. Let me walk down and go to the pump. I'll join you guys soon.
That sounds good. We'll give you 25.
Okay.
He's been really good. I've had to turn him into like an actor. We did our first, we did one just, we tried to do a video, and it was actually came out really well. But like anything, those kind of things you've got to do a bunch of times to get them right. So
you got the actor and film crew all in one there, huh?
Yes. So, yeah. So anyway, yeah, he's been great, open to do this. We've only done one of these before, and literally they said, we're going to go spec a pump. That doesn't usually happen. But it's still good to have the information. A lot of times you don't have this overall. You guys are so busy doing what you're doing. This will at least give you something. And then, like I said, when it comes to specing pumps, you just fill out a form, and if you have any questions, we're good to go. So, you guys, how many?
All right.
Oh, there he is. Never mind, he's on. So, hit him, Mike.
Thank you. So here we are. Just need to. So here it is. So we have our what you see right now is our CLP pump station, which is one of our super value engineered model. So this one doesn't have all the bells and whistles, but at least this is the smallest pump station which Rainbird makes, which we could actually haul and take it to the customer to actually demo and show the components and stuff like that. So I'm just going to go through the basic components of the, typically all the pump stations components are same. So what we see here, one of the most important component is the disconnect switch, where the main power comes in. So like you see, there is all the fuses here. So it could be single phase or three phase. So currently this one was designed for 480 volt. So, in the couple of next slides of the presentation, you'll see what are the most important factors or parameters we need to design a pump. So power is one of the main component which we need to identify before we specify a pump. So this is actually the disconnect switch where the incoming power comes in at the site. Moving along, we have the inlet, which is flanged out here. So this is the inlet of the pump where the actual water comes in. So it will be the water meter, then the backflow, then the pump station. So after the backflow, the piping or the plumbing will come into the inlet of the pump. We do have an isolation valve for the inlet, as well as the discharge. So the reason we have the isolation valves is to isolate the pump on a later time if there is some maintenance need to be done on the pump itself. So you can isolate the system and take this pump out and do the repair. The next component what we see is the inlet pressure gauge. So the inlet pressure gauge, what it shows is the incoming pressure. So the pressure which we see after the backflow. So the one of the most, I mean, not one of the most important reason why we need a pump station is to increase the pressure. So for example, the pressure is 20, the pump actually boosts the pressure and discharge it. And here we have a discharge pressure gauge. When the pump is actually boosting, it actually shows what is the actual discharge pressure. So that's the inlet pressure gauge, and that's the discharge pressure gauge. Then we come to the most important part, or the heart of the pump station, the actual pump itself. So this green component you see right here, that is the actual pump. So here we have a horizontal end suction centrifugal pump. So it's mounted horizontally. It's actually suctioned from the end. So that's why I called it end suction. And the discharge is going to the outlet. So water comes in, the pump rotates with the help of the motor and boosts the pressure and discharge to the outlet. So as you see, this is all the plumbing what you have. You can also see some of the other components here. So all the pump stations what Rainbird makes are variable speed operated. So what you see here, this gray box, that's the actual variable frequency drive, or VFD. So the purpose of the VFD is to actually regulate the speed of the pump or the motor to push accurate amount of water to each zone in the irrigation system. When when the valves comes on, one valve or two valves, depending on the flow rate required for the zone, the VFD actually ramps up the speed of the motor to push more water or less water, and it will also help to keep the discharge pressure constant. That's what we want with the VFD pump. Like, we should always get like a constant discharge pressure, which will make the irrigation system work more efficiently. Do you have, or anybody has any questions so far?
Hey, Mike, I just wanted to, do we test every single pump that we put out?
Yes, absolutely. So any pump which Rainbird manufactures, we actually test it in our facility in Tucson. So here you see, this is an actual nameplate of the pump station. It will have the job name, it will have the serial number or the job number, also have the performance, like the gallons per minute, how much will the set or design discharge pressure, voltage, and all those details. Also, you can see these Rainbird pump station service call number. So this is a service which comes along with the purchase of the pump. It's a free service. So it's a remote support line where a customer, if they have some issue with the pump at the site, they could actually call this number, and we can remotely try to rectify the issues or any alarms which is coming on the pump screen. The reason why we are confident to give this is because all these pumps are tested and we have all the test data at the factory. So when you call this number, give this serial number, we can pull up all the data, and we know how the pump was tested, at what parameters, how it's supposed to work, and they'll be able to help the customer to adjust some parameters and make it work for the system.
Awesome.
Another main
So
component.
I have
Yeah,
a
go ahead.
I have a little question. So what's the difference? Because you said it could be either one phase or three phase on electricity.
Correct.
What's the difference between that? If you could, I don't know, explain basic.
Yeah, absolutely. So so I'm going back to the actual disconnect switch. So you see, this is actually equipped for three phase, but it's the power supply which is being allotted to the specific site. So if it's a single phase power, you will only have uh, two lines coming in. So that means if a so basically, a single phase power takes more amperes or more electricity to operate a pump station compared to three phase power. If the, so, does that make it easier?
Okay, so it just kind of depends on the power allotment that they get approved for from like the city.
Correct. Yes.
Okay.
So we can manufacture uh, pump stations suitable for any phases. Like if it could be single phase or three phase. So when I know when you are designing a system, you may not know because the project is not even started, right?
Right.
So we could how we do it is we tell the architect, or we recommend the architect to put in. We can assume a standard voltage and phase. So for example, this is, it's hardly seen like 480 volts. It's higher voltage. Mostly what we see is 230 volts or 208 volt. So we could put a 230 volt single phase. That's the most common on, like, city developments or housing developments and stuff like that. And also leave a note on the plans saying that contractor needs to verify the power supply before they order the pump. So it will basically protect the designer from not specifying the wrong power, because you don't know when you're designing it. And also we'll make sure we put in the right power parameters for the pump station when we manufacture it.
Yeah, good question. And also, I think, Mike, the biggest thing, right, is if anybody can get three phase, it's just much more efficient. And
Correct.
the electrical costs go down.
Yeah. So, when we go through the slides, I will explain it a little bit more, Brandon. And then I have one or two more components I just need to cover while we are here. So there is a couple of ways we can start a pump station at a site. Does anybody have any thoughts on that?
By flow sensing.
Yep. Awesome. Any other?
Pump start relay, maybe.
Yeah. Okay. I know you know that part.
Reading the witness.
Okay. So here what you see. So the CLP pump stations comes with two options. One is the pump start relay. So this is the actual pump start relay, which you see here. So how it's connected is the irrigation controller from the 24 volt signal. It is actually connected to the pump start relay. So whenever the irrigation turns on, and if that zone needs a pump, the irrigation controller will send a signal to this pump start relay and tells the pump and the VFD to turn on. So just to give you an idea what a pump start relay is, this is an actual pump start relay. It could be a bigger panel in our bigger platform, but the actual relay looks like this.
Wow.
So how does it determine whether or not it's going to need to turn on? Is that an additional programming that needs to be done at the controller to state the amount of pressure needed, or does it sense that depending on the zone that's turned on?
So it depends. It's actually programming on the controller.
Okay.
So certain controllers, I mean, I don't think Rainbird has that capability yet. We are coming up with options. I think that on the newer IVMs we can pick and choose which stations need the pump to turn on. So from the irrigation controller, it will send a signal to the pump start relay to turn on that station or turn on the pump for that station.
Okay.
The other, typically, what we do is a flow switch or a pressure start. So this CLP pump station has a flow switch or a flow start kit option. So this is a flow sensor. What it does is when the pump operates and there is a flow through this pipe, this sensor senses the flow and tells the the pump station and the VFD to turn on and start boosting the pump. So basically, when the irrigation turns on, it actually senses the flow through the station. So that's what it's used for. So that's a flow start. There is another option also, which is called a pressure start. So it's similar to a flow start, we can say. So basically, instead of the flow sensing, it actually senses the pressure. So here we have a pressure transducer here. So it actually senses the discharge pressure. So when irrigation turns on, the mainline pressure goes low. So the sensor senses it and tells the pump to say that, hey, my pressure is going down. I need some boost. Start the pump on. So that's what the pressure start option is. So
Okay.
yeah, go ahead.
Question. So since the control or the motor is a variable speed, what is it that makes sure that you're not producing too much pressure? Like, so depending on the zone, like if it's a zone that needs, say, 35 or 40, what is it to make sure that that doesn't ramp up to like 50 or 60, or so you're overstressing the motor? I don't know,
So
did that make sense, the question?
so with the VFD pump, how it operates is the VFD controls the speed and adjusts the flow. But in the VFD, we actually set a discharge pressure. For example, if it's 20 incoming, we set it at 70 or something like that. So that it's accurate pressure for the rotors. Um, in
Okay, so
terms
that's
of
so that's set in the VFD, set that
correct.
in there. Okay.
Correct. Yeah. So always whatever the flow rate is, depending on different zone, the VFD makes sure the pump station delivers the constant 70 psi or whatever the set design pressure is. So that's what the VFD is used for. How it achieves it, it's actually by regulating the speed or RPM of the motor, how fast the pump is running, turning. So it actually regulates the flow rate, how much water it's pushing. And also, I understand that I think what you meant was like, for example, if a system has drip zone and also rotor zones, the drip zones may not need that boost pressure, but rotor zones need the boost pressure. Is that what you had in mind?
Right. Yeah. Because I was thinking if like the pump is set to operate by flow sensing,
Mhm.
if a drip zone comes on and starts to flow, is that going to kick it to boost to maximum pressure that's set by the variable speed?
It will. So one thing we could do is like, I don't know if you can see this. There is some numbers here, where you can actually set when the flow should start.
Okay.
So typically what we do is we know these small zones or the drip zones are low flow. So when we do the startup of the pump, we try to run this the smallest zone when they need to come the pump on. Like for example, only the rotor zones comes on. So we will start the smallest rotor zone and set this flow switch to only trigger the pump to come on only when they start, see that much of flow.
Okay.
Yeah.
that
So
makes sense.
below that flow rate, the pump will not turn on. Only when it hits that, for example, 20 GPM or something, that's when the pump starts turning on and then start boosting the pressure. Until then, what they do is they actually work with the available inlet pressure.
Hey, Mike,
Yeah.
with drip and rotors, like you guys been talking about, is it advantageous at all, even with the VFD, to stack, let's say, 4 drip zones together just to get a higher flow, or no?
It is. So the other option is we could include pressure regulation.
Okay.
Yeah, at the drip zones, so that we don't overpressurize those zones. uh, yeah, go ahead, Brandon.
Yeah, and that's definitely something we usually, I mean, it's standard what we do for our drip zones is we include a pressure regulator.
Yeah, that's the best way to do it, because the VFD, once it's set at that discharge pressure, it will always try to keep that system at that set pressure, and that's the actual goal of the VFD: to regulate the flow and then keep that pressure constant. And what Mark mentioned earlier was it's because, for example, the pump station. We'll cover it in the coming slides also. Like the pump station, whatever the pump is, each pump has a minimum capacity and a maximum capacity, even if we use a VFD. For example, this one here, we see it is designed for 225 gallons per minute max flow. So that's the maximum flow that pump station can achieve. But the minimum flow will be around 90 gallons per minute because, it's how the impeller of the pump station is. So in the casing, there is an impeller. So the trim of the impeller determines the maximum capacity of the pump station. So some people always think if we have a VFD, the pump could cover from this 225 GPM to 5 GPM or something like that, but it's not true. Every pump has a critical speed. We don't recommend to operate the pump below a critical speed, half of the maximum RPM. So that's why Mark was saying, in sites where there is smaller drip zones and larger rotor zones, if we need to make the pump work efficiently, the best thing is to stack the stations and bring that minimum flow higher so that the pump will not trip and not give any alarms and stuff like that. Otherwise, what happens is when the pump is running below the capable low flow, pump thinks it's actually not getting enough water, and it's actually shuts off. It's actually a safety alarm in there so that the pump or the motor doesn't run off and burn it down. So that's a low flow alarm. It'll kick on.
Very good.
Okay.
You want to move on to the slides?
Okay, I'll join you guys in 30 seconds.
Yes.
All right.
All right.
All right. See you.
Yeah. All right, we'll move into, we'll probably move through these fairly quickly, but it's really helpful, at least for me, when, Mike walks through the actual pump, because so many times, we're just looking at the specs and we're not looking at all the nitty gritty.
Yeah, really, I really enjoyed that. You get to see all the different angles instead of just what the cameraman took and what pictures are on the internet.
Yeah, exactly. Like we're gonna do now. No. This will be good though. This is actually a good follow-up. You guys can see that okay? I can start with, yeah. So this is a pressurized header. This is basically, that's pretty close to the same pump that he showed. You see a lot of same components, but we just wanted to show this. You got the backflow and the pump, and this is sort of what it looks like on one site. If it was me, I probably would have push this back a little further, you know, to have it not right next to the sidewalk, but that's just me. You know,
I'm back.
Go ahead.
Guys.
But you can do that. So the above ground tank, Mike will go into that. We've got like several different conditions. Now, you're probably just going to have, most of your jobs will be standard, but there may be every now and then some different types. And this is one of them.
Yeah, so what we are seeing right now is different types of application. The first slide which we saw is basically the boost application, where it's a city pressure which is coming in, and we are, after the backflow, we are putting a booster pump to boost the pressure for the irrigation system. The next slide, what we see is, I've seen a lot of this kind of system. So it's like a, what you call it, air gap tank system, or we call it a flood suction, because we store the water in that tank and pull the water from the tank for the irrigation. So the pressure available will be approximately like 2 psi inlet, and you know, for the irrigation, typically it will need approximately 70 or 80, depending on the site, if there is so much elevation. I've seen a lot of this in San Jose area. Even if their city water has enough pressure, they actually use this air gap tank. And I've been trying to talk to the city that that's actually not a super efficient way, because if you already have approximately 40 psi, when you push that water into a tank, you're dropping it down to 2 psi or 5 psi, and then we have to again use a bigger pump to boost that pressure back up to what's required. So instead of doing an air gap tank in those areas, they could basically put in a backflow and then connect it to the booster pump right after that. But it's just their way of doing stuff, so we don't have much say yet.
Yeah, 'cause that's interesting, because that whole tank would, I'm sure, cost a lot more than just a backflow and connecting it to the pump.
Yeah, that's right. Sorry, this is Janet. I'm sorry I was late, but yeah, we get a lot more of that in different cities where they want these air gap tanks, and it's just such a waste of money to me, because
Yeah.
really, you could do the same thing with a backflow preventer, way cheaper.
Yeah, exactly. Like, it's a waste of space. It's like a structure which is standing up in the middle of a parking lot or whatever. And so we are trying our best to convince people not to do, I mean, if not really needed, they don't need to do the system. Typically, why they need air gap tank is if they have a well at a site which they're drawing the water from, they can store this water in the air gap tank, and then they can pump it from there for the irrigation. That's the best way to use, or where we recommend an air gap tank system.
Yeah, the other thing is rainwater catchment or gray water. We do the same thing.
Yeah. Have you guys seen a lot of rainwater harvesting systems up in?
Yeah, actually, San Francisco now is, I think, a mandate where if any new buildings have to have rainwater catchment.
Awesome. Yeah, Rainbird has a system, and I've seen it a lot in LA area.
Yeah.
Get lots of requests, and then Mark and I, we can share like a typical system, but mostly what we have seen is the maximum flow for that system is designed like 25 gallons per minute.
Oh yeah, we do drip mostly.
Exactly. Yeah. Okay, cool. And we'll have like a mini filter system in there, self-cleaning filter. So because it's rainwater, harvested rainwater, so we want to make sure the drip line is protected. So it's a mini incorporated package system, which is pretty value engineered as well. So
Yeah, I'd love to see the literature on that.
yeah, absolutely.
Okay.
So talking about the rainwater harvesting system, this is a similar, but we call it a suction lift. So, you know, if you think about the rainwater harvesting system, as you see in the slide, the water is being stored in a cistern below grade, and then the pump is mostly installed above grade, where we pull the water from a tank and then use it for irrigation system. Another scenario what we see is this are more for lake or massive developments or parks stuff. So if there's a lake, there's a scenario where the customer will want to build a wet well beside the lake, and we'll have like an intake line from the lake to the wet well. So as you see in the picture, the water level in the lake will be same as the water level in the wet well. So they are basically pulling the water from the wet well and boosting it for irrigation applications. So we've done multiple stations. What we're talking about is like 1,000 gallons per minute, 1,500 gallons per minute. And lots of times golf courses also use these kind of systems. And these are a couple of $100,000 worth pump stations. So we have the capacity to do that too.
To do 5 of those?
Every year.
We've run into it a couple times, but not very often in our landscaping. We did, I think, a cemetery once that had a lake.
Awesome. Yeah, Jen, we did the, in 2019, we did the Riverside National Cemetery,
Oh,
the newer phase 5. And then now we're working with cemetery to upgrade their 2 of the older sites, which had older pump stations. So we're proposing new pump station. We're working with an architect or a design engineering company up north called VTI. They're the ones who's designing the retrofit, and we are helping them supporting with the pump station. So please keep us in mind if you have opportunities like that. We'll definitely be able to help you out. Moving on, another scenario which we see, this is also a suction lift type station. We've done a couple of these in Northern California, Auburn area, where there was like regional park. They used to have a wet well type system, but then it was like 30-year-old, and the city or the park district didn't have money to build a new wet well system. So we proposed something like this, suction lift, where a pump can stay beside on the bank of the lake, and we are pulling the water from the lake and use it for irrigation. So we propose, they used intake screens to filter the water which is coming from the pond to the pump. And also we used a secondary filter downstream of the pump to clean the water before it's being pushed to the irrigation main line.
All right, Mike, if you let me, I'll cover the flow range. How's that?
Okay.
This, I think we've already talked about this a little bit when Mike was going through the actual pump, but things to keep in mind. These are items that we ask on our job information form, and they're obviously critical to sizing the pump correctly. So we got to know the minimum flow. So if you've got drip zones like we talked, maybe you're going to stack those where you're doing 2 or 3 or 4 drip zones going at a time. Then also we need to know the maximum flow when you've got all those rotors going, or whatever the combination is, but we need to have that parameter. Otherwise we can't size it correctly. So the flow range is super important. Mike's also going to talk a little bit about the available pressure. We all know, I think, a lot of the basics. So static versus dynamic pressure.
Yeah, so static pressure is the pressure available, when there's no water moving. So it's basically static. The dynamic pressure is the pressure when the water is moving in the irrigation system. So it's different. Always the dynamic pressure will be lower than the static pressure because in the dynamic pressure, we are considering the elevation losses, uh, the the bends, the friction losses through the pipes and all this stuff. So when you are designing a system, it's hard to know the dynamic pressure, but the way we figure it out is using the critical loss calculations, which you do. So, on that, you list out, the backflow losses and elevation losses, the other friction losses and stuff like that. So,
Yeah, recently, the last 2 months, we've been going through that pretty hardcore here. So
yeah.
Good.
making sure we know how to do those
And hammering
losses.
that into their head.
Yep. It's really important. And, so one thing what we need is we need to know how much pressure we need to boost. So dynamic pressure is mostly important when we are going in and retrofitting a system, an older pump station, or a site where they didn't have a pump, and now they would like to have a pump. So typically school districts, which may need a pump 15 years ago, but now the pressure has gone down. So now they need a pump. So I go to a site and check the static pressure at the backflow, after the backflow. When there's no irrigation running, then check the gauge pressure when the irrigation is running. So you'll definitely see that it will at least go down like 5 to 10 psi.
Quite a bit.
So
All right. Location of your pump, we're showing two different situations, but it's another question that we ask on that GIF form. So some, could be in a vault, could just be outside. And Mike, didn't you say do we have some custom options for painting?
yeah, so typically if we supply pump stations for military sites or Air Force sites and stuff, they have their own camouflage color or different custom paints they want. So they would request special painting. We did that Riverside National Cemetery pump station. It's completely purple pump station, which is standing in the middle of a beautiful landscape.
Oh,
Because it's a recycled water they're using. They wanted it. So if the customer wants it, we can customize it whatever way they want. We have the capability. So, Mark, could you please go back again?
for you, maybe.
Okay, so here what you see is if a pump is installed in a pump room, you don't need an enclosure because the pump room acts like an enclosure. So on the right side, you see that it is installed in a pump room. So because the enclosure is to protect all the components because we have the VFD in there and sensors and stuff. So we don't want it to be exposed to the environment. That's the goal, to put an enclosure. So just wanted to clarify that. Yeah, so power. So Brandon, you asked the question earlier, what are the power differences? So here you can see the single phase and three phase. So the basic difference is if a pump is operating at a single phase power supply, typically I would say if it is about 7.5 or 10 horsepower, if it's running on a single phase power supply, you're actually consuming more electricity during the operation of the pump station. So below 7.5 horsepower, we don't see that much of cost increase in energy consumption. we could recommend to the customer like, hey, this is 7.5 horsepower or 10 horsepower and above. Yeah, let's, if possible, we can go with a higher voltage, like 480 volt or 460 volt or a three-phase power supply, so that their operational cost through the coming years are less compared to using a single phase.
So
I don't-
what is the standard range of horsepower between the pumps you guys produce?
It's it all depends, brand. So all depends on the flow rate and the boost pressure needed for site. So typically 90% of the pumps we sell in California, I've seen it below 15 horsepower, or I mean, I would say below 10 horsepower. So single phase should be fine. But if the customer has a three-phase supply, and or any of this voltage is listed, Rainbird has the capacity or capability to manufacture the pump station based on what the customer has at the
Okay.
site. Yeah.
So Brandon, typically we have 3 to 5 horsepower for our systems because they're fairly small. Just so you know.
Yeah. So the lake pumps, which we saw earlier, about 100 horsepower, those are massive. So those ones 60 volt or 480 volt three-phase. So because we want to prevent or we want to reduce the operational cost of the pump station.
Yeah, that makes sense.
All right, I'll do, looks like a lot of boxes on this, but this is our job information form or GIF form. And if you look, we'll send you guys an Excel spreadsheet. It's actually really simple. You know, it's got these 4 steps and it's just making selections. What that does is you send that back to me or to Mike. We work together on that, and then he'll come up with the actual pump spec, the details, everything that you need. And then if anything changes along the way, you know, the next few months, which it happens all the time, or you get some, you know, there's a new higher GPM or whatever that is, he'll make those adjustments. And then we record that. Now we also have this online. I sort of prefer the Excel spreadsheet myself because then we sort of know what's going on. Online, we do know what's going on, but it is another option where you could literally go on the website, put the numbers in, and they'll put out a quote for you. But I'm sort of old school on that. I'd rather go with Mike and see a person. So that's just me.
Yeah.
These
And
are
Mark, I just wanted to add something really quick.
yes, sir.
It's just you know, we've been in the market for so long, and in the market that Rainbird is very expensive pump stations compared to other manufacturers. When I started with Rainbird 3 years ago, that was the situation, or that was the talk in the market. The reason is because the job information form which you saw, you know, if we don't, we would definitely hold hands with you on this, because sometimes some designers just tick every boxes, and then we basically code a pump based on including all those. But let's talk on projects, and you may see me asking more questions because I want to make sure we propose the most value engineered or cost efficient pump stations for you. Because instead of paddle wheel flow meter, if we add a magnetic flow meter, it will bump up the cost $6,000 or something like that. So so there are ways to keep the cost low. So we've been really successful in the past couple of years, and we've been really competitive also. And Rainbird is being more flexible, and they are driven to improve our pump stations and you know, bring in more to the market. So Definitely, if you are in doubt, just give me a call or give Mark a call or put it in an email, and let's if it is really needed for that site.
Thanks, Mike. So these are the specs that we provide, and the cut sheets for your plans. This is this cut sheet. Pump tech spec is a little bit more standard, but this will have all the other information on there, so you can just put it right on your plan. You don't even need a sticky back, if you know what that is. Somebody does.
I do.
I always think of sticky backs when I see these, like cut sheets and stuff. I'm like, yeah, sticky back.
No, we just paste them in on CAD now.
Yeah. How about that? Thank
Do
you.
you have details too, or never mind.
Yep.
So
Definitely.
these are just some more of the drawings. Mike, I'm going to keep moving only because
Oh yeah.
we're getting on the hour here. So here's the turnaround time is really fast. Sometimes it's faster than even what I have on here. Mike I know he works late at night. Sometimes we both do. Last night, I think we were doing a pump spec until about 10:30 or 11. So it wasn't that it was even a rush. We just want to make sure that we get them done. So you can see the different platforms. If you do something like a custom platform and a much larger pump, it may take us, 72 hours to turn it around. And now Rainbird, we have quite a facility for the pumps if you guys haven't seen it. And of course, it's going to be a while before we can have fly-ins again. But it's impressive, and we can get things done very quickly. So 3 to 6 weeks, small platform, and then 6 to 12 for large. So I think that's another reason, Mike, when you're talking about the cost. And Janet, I was going to tell you that it's been interesting because just in the couple of years I've been up here, with Mike, where we've gone through and sort of done this and talked about job information forms, whatever. People have done comparisons. I think they like the main fact of us getting back to them with the right information and following through all that. But I know we have to be competitively priced. So I think we've already turned at least 6, 7 firms to, now to 100% Rainbird on the pumps. And I think the cost is part of it. So this is our support team. You can already see us. So that's when we get to go on a road show, we can actually get out there, but this worked out great. I think Mike knows how to do this. And he's my guru. So this is in San Francisco when you used to be able to go to San Francisco. So I said, ask Mike T. It's easy to remember. The last thing, it's only if you guys have time, it'll take about a minute, 2 minutes. Our catalog. Well, first, is there any other questions on pumps while I got Mike?
Yeah, thank you, Mike. That was really, really informative. I appreciate your time.
Thank you all for giving us the opportunity. I know we've been trying for some time, but I know you all are busy, but I really appreciate you guys' time too.
Cool.
Thank you.
So what I was going to show you is we're not doing a catalog this year, which I wasn't too happy with at first. And then I'm like, so what are we going to do instead? And, a lot of times Rainbird's done this before, and then we end up doing something on our website, or, say, hey, go to the web, or even at one time they did a CD that didn't go over. But now we've got a new Rainbird app resources, and I'll tell you the advantages. And I know because I'm big on catalogs. I gave out 400 last year. I think to you guys probably 5 or 6. So this goes up like this, and it's what I like about this is it's up to date. I mean, every day we update, whether it's new products or whatever. Where you get a paper catalog, it's out of date with Rainbird at least within 15 to 30 days. So I've already had 2 new products since I got this app just a few weeks ago. So you can literally go to like catalog. And the nice thing is while you're working on the computer, sort of like with a hard copy catalog, you can look to the left and to the right, just like you would do. But now I can quickly get to, like, if I want to know all the new products, because Mark hasn't given me updates, I can go right here and say, oh, man, I didn't know you guys had a zero bug with a check valve, or this one I did send out to you guys. You should have got it. So this is a new product, the flow indicating basket filter. Or you can go quickly to tech specs, you know, the different models all the way down, and then any documents which might be, I like tech specs myself. I feel I get all the right information on those, but you can see how quick. So the other thing it has, when you go back to here, you can do literature. It has Mwello on here. We've got all the different tables. So you've got all your friction loss tables on here. So for me, it's great too. So if you ask for something and you don't have time to do this, I'll obviously send you a link, you know, so you can get it. But anyway, it's a great. So all you do is go, it's a free app. Just go to your app store and then do the Rainbird resources and bring that in. And the other thing too is even like the search. I haven't liked our search engines before, and we've definitely improved it on the website, but also on this, so you can switch back and forth. Like if I couldn't remember the name of that product, I could go basket, and that's all I remember. So I do the search on that, and then it's going to bring up anything, obviously, with baskets. So now we're back to flow indicating basket filter. So anyway, that's about it on that, unless you guys have any questions.
No, is that accessible online as well, or only on the cell phone?
No, not online. But you'll find out that I've seen we're making the website actually match the app and back and forth on that. So we've been able to do the two. In fact, we're even doing, this will come eventually, but we're going to do some kind of a quote feature. So you can literally just pick 3 or 4 products and it'll give you the price, which is nice. There's a price list on here too. So, but
So
yeah.
So Brandon, you can probably load the app on your PC, right? I mean,
Yeah, you could. I haven't done it, so maybe I should try that. So,
yeah.
you guys can do the next one of these. Show me that app on there. But yeah, if you can do that, I just share this on the Zoom so you can see it on your phone, because I think that's a part of it that I started playing with it, and I'm like, I tried my catalog and then I tried this, and on my timing, I'm probably at least 10 times faster because we have so many products. So it may not work for everybody, but I think it'll do fine once you're used to it.
I like the catalog.
Great.
Are they going to do paper catalogs at all, or just not at all?
Not at all, unless you want the 2021, or you want me to individually print them off the.
I'm kidding.
No, actually, I thought about that. I was going to my boss. I already had a plan. I was going to do I don't think you've seen me do my golden ticket. I already had a golden ticket, and maybe I'll find something else to do it with, where every 30 catalogs, I put a $25 gift certificate in a gold ticket. So it's sort of like Willy Wonka, you know, but then people seem to want catalogs when you have a giveaway. So anyway, but it's sort of fun to do that. I have to figure out how to do it with this. Maybe if you find the golden egg inside this, maybe I'll figure something out. So we'll plan it every so often. You know, we can plan it in different locations. Maybe Brandon can find it.
Yeah.
Yeah.